Hi, my name is Nilesh Acharya. I'm a Senior Program Manager working on automated machine learning. In this video, we're going to see how you can use automated machine learning to help build and accelerate building machine learning models. Let's look at a typical example of how you would build a model. Data is generally in disparate places. You bring that data together and prepare it for model training. You then go ahead and train a model. And once you're happy with the model output that you've got to, you go ahead and deploy it. Now, this whole process is a number of steps and interconnected decisions that you would make to get to the model accuracy that you're looking for. For example, when you're preparing data, you may ask yourself, how do you handle nulls? Do you have the right number of features in that data set to prepare a model for the accuracy and scores that you're looking for? And when you're building in training, what algorithm should you select? Should you be selecting a linear regression or a decision tree? And what are the hyperparameters that you need to choose for those specific algorithms? So as you can see, there's a number of questions you may be asking yourself through this process. Let's examine this with a specific example. If we were to predict how much is a car worth, we may look at the features that we need to predict and build the model, the algorithm that we need to choose and select, and the hyperparameters. So let's start with mileage, car brand, and year of make. We then select a gradient boosted algorithm and its relative hyperparameters associated to it. We then get a model score of 30%. Not being too happy with this, we go and retry with some more features, a different algorithm, and a new set of hyperparameters. We do see an incremental increase reaching 50% accuracy. Again, not being too happy with this, we go ahead and retry this whole process. We continue trying over and over again until we get to a score that we're happy with, let's say 95%. We then have reached a score that we now have a model that we're going to go ahead and deploy. As you can see, this process is very iterative, taking time and always guessing to where you need to go next. So what if there was a way to automate that process? And yes, there is. That's exactly what automated machine learning does. With automated machine learning, you enter your data, you define your goals, and you apply your constraints. Automated machine learning builds an end-to-end pipeline that allows you to build a model and reach an accuracy score quickly and effectively. You can get an optimized model with far fewer iterations and far fewer steps, saving you time, money, and resources. This helps you scale out and build more machine learning models with greater speed and accuracy. Automated machine learning basically simplifies the process of generating models tuned from the goals and constraints that you define, such as the time for the experiment to run, which models to allow or deny, how many iterations to run, or an exit score that you may have defined. Automated machine learning isn't a brute force attack, nor is it doing a hyperparameter sweep. Automated machine learning is using machine learning to help you build machine learning models. Based on Microsoft research and work done from our engineering teams, automated machine learning examines the data sets that you have and the characteristics and recommends new pipelines to use to build your machine learning model. This encompasses pre-processing steps, feature extraction, feature generation, model selection, and hyperparameter tuning. Automated machine learning also learns from the metadata from your previous iterations to recommend new pipelines to get to your scores and exit criteria much quicker and much sooner. This helps accelerate your ways of building machine learning models with more efficiency and ease. To get started with automated machine learning, please refer to our documentation, sample notebooks on GitHub and blog posts. I hope you enjoy using automated machine learning, and thank you for your time.